I wonder how much it's going to cost this time. I just got $30 worth last week. Man, I really wish I didn't have to spend this much money on gas. Where would it really be going? I know that there's not a leak in my tank because it's a new car. Well, I don't have a cap. I guess I shouldn't have left it at that gas station. Maybe it's just disappearing.
I think I may have just the experiment to explain where the fuel in your car is disappearing to. But before we can dive into that, we must ensure you have the proper knowledge to understand our experiment.
Let's talk briefly about the properties of solids, liquids, and gases. Here are the three states of matter: solid like an ice cube, liquid like water, and gas like water vapor. A solid is stable and has its own shape. The molecules vibrate slightly and are grouped together in organized patterns. Solids can overcome the changes of sublimation and melting. Sublimation is where a solid is turned into a gas, and melting is where a solid is turned into a liquid. A liquid shifts to fit a container they are in. A liquid does not have their own shape, but can take a shape. The loosely packed molecules move around fluidly. Liquids can overcome the changes of evaporation and freezing. Evaporation is where a liquid turns into a gas, and freezing is where a liquid turns into a solid. A gas has free-flowing molecules without a definite shape. A gas can fit and fill a container. Gas can overcome the changes of condensation and deposition. Condensation is where a gas turns into a liquid, and deposition is where a gas turns into a solid. In the video on the right, you can see a fire extinguisher being used to create dry ice.
These states of matter can undergo physical and chemical changes. A physical change is how a certain substance can form into each different state without changing the substance that it is. Like when water is boiled, the bubbles that form are releasing water vapor into the air. This vapor is still H2O, but in a gaseous form. A chemical change is when a substance undergoes a chemical reaction and the makeup of the substance itself changes. So what does that mean? Let's find out. Like we saw in the gas tank earlier, the substance seems to be disappearing during a chemical reaction. So what's really going on here? If you haven't heard of an Alka-Seltzer tablet, it's a common household item that when dropped into water, it begins to bubble or fizz. This is a loose representation of the phenomenon that is happening to the gas inside of your car's tank that causes it to disappear. To figure out where your gas is disappearing to, we must use mass as a driving factor in our experiment. To begin, we will need the following: safety glasses, water, a balloon, a scale, a medicine bottle with a cap, and last but not least, Alka-Seltzer tablets. Once we have gathered our materials, we should first measure the mass of all items being used in the first demonstration. The mass of this uncapped medicine bottle is 8 grams, as shown on the scale below. Now, we have added 40 grams of water, making the total mass of the bottle and the water 48 grams. Up next are the Alka-Seltzer tablets. We will be using 2, and as you can see, their mass is 6 grams combined. Now that we have properly massed all materials, we will add the Alka-Seltzer tablets to the bottle filled with water and see what happens. When the Alka-Seltzer hits, we see the white fizzy bubbles rise and fall in the bottle. Now let's mass our final product. Our final mass is 53 grams. Wait, what? How can that be? If you remember from before, we had 48 grams for the water in the bottle. We had 6 grams from the tablets. That's a grand total of 54 grams. How did we lose an entire gram of mass? Where did it go? Did it disappear? Make your prediction now. Maybe we lost the gram through the open top of the bottle. If we put a cap on the bottle, all the mass will have to stay inside. None can escape through the top. If mass is successfully contained within a system like our bottle, we consider that system closed. On the other hand, There are open systems that allow mass to escape, like our first demonstration. Let's close the system with a cap and see what happens.
Safety first.
As you can tell, placing the cap on the bottle did not fully close our experimental system. The cap popped off forcefully, which means we still ended up losing mass, probably more than the last time. So far, we've tried 2 open system models, once with the cap off and once when the cap popped off. If only there was a cap that was a bit more flexible, then our system would be closed. That way, we could discover where our missing mass is going. I think I know of a material that can stretch to fit over the top of our bottle and give our system a chance to expand. A balloon! Thanks, Mr. Clown. For our final demonstration, we will cover the opening of the bottle with a balloon and see what happens. As you can see in this video, when we give the reaction a little room to flex, the balloon actually swells. So, was the mass just disappearing? No! The missing gram of mass from our original demonstration was released in the form of a gas, never to return to our bottle again. This was a chemical reaction. The law of conservation of mass states, mass is never created nor destroyed, it only changes state. So when you're driving or riding in your car, the fuel does not simply disappear or leak out, it's being converted by way of a chemical reaction to a gas that is released through your exhaust pipe. In conclusion, mass cannot simply disappear. It changes forms. What else in your daily life seems to disappear?